And welcome back to Loving the Physics with Mr. Goldthorpe. Time for Unit 2. We're going to go into 2D. Okay, so I'm going to get you guys to turn to Lesson 1. And let's talk about how to deal with two-dimensional vectors. You see, in the previous unit, we were actually dealing with 1D motion, where, it might be going, let's say, to the right or to the left. And so we made one direction positive and the other direction negative. You can do the positive and negative thing if there's only two directions. But when you bring into a second dimension, so for example, and I'm just going to show this with a different color. If you go into 2D, now we have two axes. Now we have a Y and an X. And you realize that now there's actually not just two directions. There's a lot of directions. You can have this direction and this direction and this direction, etc. There's an infinite number of directions. So you can't call one direction positive, another one negative. So how do we show direction then? It turns out there's a couple ways that we can actually do that. The first one, and this is going to be the most important one, it's called the News approach, if you wish, or the north, south, east, west approach. So I want you guys to take a look at the vector on the right hand side with the 60-degree angle with the north, south, east, west. And let's say that we want to actually identify what the angle happens to be. Well, it starts out easy. It will be 60 degrees, that's for sure. That angle always has to be less than 90 degrees when you're actually dealing with the north, south, east, west approach. But then what happens is you'll have blank of blank. And this is where you put the axes in. Now what you guys need to remember is that the second letter here is the axis that the angle touches, or the starting axis. So if you take a look at the arc of the 60 degrees, you can see that it's definitely touching the west axis. So if it's touching that axis, then that's going to be the second letter. So this is kind of where you're starting your angle. Now the first one is where you go from the west, and you'll see that you're basically going up towards the north. So we would call this 60 degrees north of west. Just keep in mind the second letter is the axis it touches, or the starting axis, and then you're good to go. So that's the news approach. So we use this almost every single question. There is another way though, and that's called the RCS approach, otherwise known as your standard position approach, something you might see in Math 30-1, for example. So in this case, we're going to introduce some axes. Here's your Y, and here's your X. And the way this goes is you always start at positive X. So this is your start axis. And then from there, you go all the way to what's called the terminal arm. So you go from here all the way to here. Now, if you go in a counterclockwise direction, like this, that would be considered a positive angle. So counterclockwise is positive. So this one would actually come out to be positive 120 degrees. And that would be the angle. So this would be either positive 120 degrees, or if you wish, you could go the other way. I'll show this kind of as a dotted arrow. Going the other way, see that's going in a clockwise direction. And that'd be like 90, 180, 240. This would actually be negative 240 degrees. Negative because it's clockwise. So either of those two angles is considered acceptable. We will not use this much at all in this unit. Most of the time we're going to be dealing with north, south, east, west. Good, so make sure you're comfortable with the second letter is the axis it touches. All right, now it's time to do some addition. So when you add in two dimensions, it looks a little different than what we've been doing up till now. Imagine you have these two vectors here at 90 degrees to each other, and we want to add them together. Well, here's what it would look like. So we'll start with V1. You'll see how V1 is going this way, so I'll just label that as V1. Now, when you add these two together, I want you guys to remember a very important phrase. To the tip. That means you have to take the second vector, which is V2, and you add it to the tip of the first vector. So here is the tip of vector 1. From that tip, you're now going to add V2. And believe it or not, that's called addition. Now, what's the answer? And it turns out the answer is otherwise known as the resultant. And the resultant, the way I want you to remember it, is kind of like displacement. It goes from start to finish. So you see how it started here at the beginning of V1. It finished over here at the end of V2. So you just go straight from start to finish. So that is called the resultant. That's the sum of those two vectors. And then when it comes to the angle you show, angle has to always be at the beginning of the unknown vector, or your answer vector. So you'll see how the beginning of R is on this side here. So that's where theta goes, at the beginning of the answer vector. Good? So this is our triangle, then we simply solve the triangle to finish the question. This is called tail to tip addition, but I want you to remember to the tip. Now before we do an example, this is an excellence level idea. What if we want to do vector subtraction? What if I wanted to find V1 minus V2, for example? Well, what you do is you change this to addition. This becomes V1 plus negative V2. So if I then take V1, which is going this way, so there's V1. Now remember, you add the next one to the tip, which is right here, but you add the opposite of V2. What direction do you think the opposite of V2 would be going? Well, V2 is going up, so the opposite would go down. There's negative V2. And again, the resultant goes from start to finish, like that, at some angle theta. So that's called vector subtraction. This is strictly excellence level. You only have one, maybe one small multiple choice question on this. Otherwise, the most important thing is doing vector addition. Let's try one together. So here I have a classic question. A hiker walking from a cabin, and we're looking for her overall displacement. I recommend you guys, can you just, we're going to add these two vectors together. Do you guys want to try to draw the diagram yourself? Just pause and try to draw it yourself. Okay, let's draw this. So we know it's going to be going 40 meters west first. So this would be 40 meters. Then again, we're going to add on to that 70 meters north. So to the tip of that, we add 70 meters north. And the resultant, which is the overall displacement, goes from start to finish. From start to finish. That's your overall displacement. And you got to put the angle at the beginning of the unknown vector. When you're drawing these diagrams, make sure you guys draw them as arrows, not just lines, and label all the sides and the angle. Okay, so now we've got our triangle. All we need to do now is to solve the triangle. So we start with doing the Pythagorean formula to find the magnitude. So we have c squared equal to a squared plus b squared. Just remember that c is a hypotenuse. So if we get c by itself, it becomes the square root of a squared plus b squared, or delta d becomes equal to the square root of 40 squared plus 70 squared. All right, so let's do that in our calculators. And to two significant digits, I get about 81 meters. Okay, so that's the magnitude. But you're also asked to find the direction. We need to find theta. So to do this, let's do a little review of trigonometry. I'll just put over here, we have SOHCAHTOA. Now, remember, you identify these things relative to where the angle happens to be. There's the angle, and on the exact opposite side of that, which is the 70, that would be considered opposite. And the other side here would be considered adjacent, and of course the delta D is the hypotenuse. But on the diagram, we have opposite adjacent. That is TOA, that'll be tan. So we have here the tangent of theta is equal to opposite over adjacent. Or the tangent of theta is equal to the opposite, which is 70, over adjacent, which is 40. And all we do now is take the inverse tan of both sides. So we do the inverse tan of that to find the angle. The inverse tan is how you find angles. And this becomes equal to, make sure you guys are in degree mode, by the way. So we get about 60 degrees. But 60 degrees relative to what? So 6 degrees, something of something. All right, I'm just going to do a little erasing here. And I'm just going to transfer, I'm just going to copy this diagram down to here so I can actually use it again. There we go. Let's now put on the north, south, east, west. So again, we have north, and below is south, then we have east, and then we have west. But notice I only labeled the axes that actually are kind of related to this vector, north and west, which means we only have two choices. It's either going to be north of west or west of north. Just remember this. The second letter is the axis it touches. Well, it's touching this axis down here, which is the west axis. So west goes here, and you're going north from there, kind of like the example we did at the very beginning. There's the direction, and up here is the magnitude. And there's our answer. Okay, so for these questions here, the most important thing to start off with is to draw a proper vector diagram. We're doing that all the way through this unit. So you guys make sure you draw very good diagrams. Arrows, show the arrows, label all the sides. And then just a little bit of trig. Pythag, SOHCAHTOA, and you're on your way. Okay, so that's enough to get at least some of that homework done. And I'll see you here for the next part.